uh, whenever we think about resistance, we always associate it with losses. More the resistance, more will be the losses, less will be the efficiency. But that's not always the case. Okay, so let's see why. Um we all know that a simple RC circuit, whether it be source, like either it be charging, the capacitor will be charging, or it may be discharging, the time constant is given up by RC. So before getting into the practicalities, let's first see how this time constant affects the circuit. If the time, let's consider a RC charging network. We give a step input, and that goes on charging. Now, one time constant is the time time taken for the capacitor voltage, the voltage across the capacitor, to reach 63.2% of its final value. What is the final value of the circuit, you say? It is the step input, the step voltage. Okay, so 63.2% of uh, voltage A will be the time, will be defined as one time constant. Now, if we increase the resistance R, what will happen? If we increase the resistance RC, tau equals RC. So, if we increase the resistance, the time taken to reach the same voltage will be higher. Okay, so increase the time constant will increase the time to fully charge the circuit. Okay, so to fully charge the circuit takes around 5 tau. It is just an approximation. It reaches around 99.8% of the final value, so it is a good approximation. So 5 tau is the time taken to fully charge the circuit. Increasing the resistance increases the time constant, which in turn increases the time taken to charge the capacitor. Now, let's see it practically. Okay, uh, let me clear it out. Okay, okay. If we now see it, what will the resistor do? What a resistor does? Resistor opposes the current. So higher the resistor, lower is the current flowing through it. Now, what do we know about current? Current is the amount of charge flowing per unit time. Okay, so if we assume a volume, it is a conductor. So from this cross sectional area, the amount of charge that is flowing through in a particular time is known as the current. So resistor is known for decreasing the current. So if the current decreases, the amount of charge that is being deposited at this plate, the capacitor plates, decreases. Now the voltage across the capacitor, the VC is defined as, we all know Q equals CV, hence we can say this as Q upon C. So if the charge deposited at the capacitor plates is less, the voltage will be less. Okay, so this is making complete sense. But what about the RC discharging network? Okay, when uh, when the capacitor is when there is a source free RC network, if R, this is C, so the capacitor will be discharging. So intuitively thinking, if the resistance increases, what do we know? If the resistance increases, the loss should be higher. So the capacitor should take less and less. Increasing the resistance, if the resistance increases, the capacitor should take less and less time to discharge completely. Okay, to discharge completely, the capacitor should take lesser and lesser time, because the resistance is increasing, thereby consuming more amount of energy. But again, the time constant is defined by RC, which means that capacitor will take even more time. By increasing the resistance will make the capacitor discharge slower. This is completely counterintuitive to what we have actually seen. But uh, see, resistance is just an element which opposes, it is a rough path for electrons to move from. Okay, so the faster it tries to move, the higher the energy is dissipated. So uh, the correct way to think about it is, see, what does a capacitor do? Okay, let's analyze a capacitor's behavior from the very basic. Okay, what is a capacitor? It is just a plate with charges upon it. The higher the charges, more will be. See, the distance up between the capacitor plates is fixed. So Q equals epsilon naught A by D. D is fixed. The area is fixed. So the charge defines the voltage between it. Higher the amount of charge deposited, the higher will be the potential difference across these two plates. So higher the charge, higher will the potential difference, higher will be the energy stored by the capacitor. So how does the capacitor dissipate its energy? It is just by the movement of charges. So higher the amount of charges, higher the amount of energy, and higher will be potential difference, and the faster will the charges try to move. Okay, so the resistance, increasing the resistance, we know what does a resistance do. Resistance is known to decrease the amount of current flowing through it. For a particular potential difference, if the resistance increases, the current flowing through it should be decreased. It's simple Ohm's law. V equals IR, delta V equals the current times the resistance. If the resistance increases, keeping the current constant, keeping the voltage across it constant, the current should decrease. Okay, so the current is decreasing, and by our previous analysis, what we know about current? Current is just the flow of charges per unit time. Okay, so if the resistance increases, the amount of charges that are flowing per unit time will be reduced. And where are the charges coming from? From the plates of the capacitor. So the capacitors, the rate of discharge of capacitor, that is the rate of flowing of charges from the capacitor to the ground, will be reduced. In return, discharging, the rate of discharging of capacitor will decrease. Okay, so this is the correct way to analyze, and this is a very good strategy of confusing you. Whenever you attend a technical interview, you will be first given a different perspective. You will be made to approach the question from a different perspective, and hence you will be confused. So never get confused. So this is a very interesting tactic used by interviewers to check your basics. So stick to your basics, understand, analyze, and understand everything, every circuit, every minor thing from its basics. I hope you learned something from it, and happy learning.